These are the 3.1 notes, functions and function notation, page 2. So at the top, we have an example from the text. We've got 3 items and their prices. And so A asks, is price a function of the item? Which means, given an item, is there only one price? And that's going to be a yes. So yes, and we want a little explanation. Given item, there is only one price. So now, based on this menu, is item a function of price? And here we've got a no. Because if we're given a price of $1.99, it could be a jelly donut or a chocolate donut. And so we've got 2 options with that $1.99 price. That input of $1.99, we've got 2 possible outputs. Could be a jelly or chocolate donut. Okay, so it is a function going one way from item to price. It is not a function going the other way from price to item. Let's look at this a little different. We want to find the domain and range from a set of ordered pairs. And so here, the curly brackets means we're talking about a set. We've got parentheses in there telling us these are ordered pairs. So in A, I have a set of 3 separate points, so 3 different points there. My domain, I'm going to see if I can do this numerically. I've got a 9, a 9, and a 2. So my domain is 2 and 9. Notice that I do not need to repeat that 9. It only needs to be stated once. My range, let's see if I can get them in numerical order. I've got -5, 5, and 4. So -5, 4, and 5. Is this a function? No, it's not. Because 9 gives both -5 and +5. So that input of 9 gives me 2 separate outputs. So let's take a look at B. My domain, all possible x's. Let's see if I can go numerically. I've got -2, 0, 4, and 5. My range, I've got -2, 1, 5, and 7. And notice each of my x's is different. So yeah, this is going to be a function. And let's take a look at C. Here's my domain. All possible x's, I've got to numerically. I'm put them in order there. -5, 0, and 6. My range, each of these goes to 3. So my range is just 3. Is this a function? Yeah. If I give you a specific x, you will tell me that y is 3. That's the only y that goes with each of those x's. Part 2 here, example 5. We want the value of a function. We're used to seeing things in terms of y equal. Okay. We need to be able to find an output given an input. So we want to know what x goes with, what y goes with a given x. So we're going to go x equals 0. Y is going to be 2 times. We are just going to plug in our x, figure out what y goes with that. I get 0 minus 0 plus 3. I get y equals 3. I can do this again with x equals 4. Y equals 2 times 4 squared minus 4 plus 3. 4 squared is 16 times 2 is 32. Minus 4 plus 3. And I get a y equals 31. And if I plug in, what's my last one? X equals -2. You know what? I'm going to try to cram this in up here so this is all a single page for you. So let me shrink that down. We're not going to go on to the second page. We are going to substitute in x equals -2. I get y equals 2 times -2 squared minus -2. I'm going to be very careful about my signs there. -2 squared is 4. Times 2 is 8, minus a -2 is plus 2 plus 3. I get y equals 13. Let me make sure those stand out. So we have a second equation, y equals 5x minus 12. We're going to plug in the same ones, x equals 0, y equals 5 times 0 minus 12. 0 minus 12, so I get y equals -12 when x is 0. If I plug in x equals 4, I've got y equals 5 times my 4 minus 12. Again, 20 minus 12. As far as the work you need to show, you guys, you don't have to show me that 5 times 4 is 20. I'm going to assume that if you show me 5 times 4 minus 12 and you just put 8, you're okay with what is going on. So here I got 5 times -2 minus 12. I tend to get confused if I'm trying to talk and write at the same time. So I typically will write out all the steps just so I don't miss anything. And here I get y equals -22.